Let's take a look at example 3. A newspaper delivery person in a car is tossing folded newspapers. The height of the papers as he travels is modeled by negative 12x squared plus 21x plus 2. Use the quadratic formula to find out how long it takes the papers to reach the ground. All right, so we need to figure out where does this function cross the x-axis. In other words, solve this using the quadratic formula. So x equals negative b, so negative 21, plus or minus the square root of 21 squared, minus 4 times a, which is negative 12, times b, which is positive, times c, which is positive 2, all divided by 2 times a, which is negative 12. On this one, doing a little bit of simplifying, I get negative 21 plus or minus the square root of 537. Divided by negative 24. Now, this is the exception. We're dealing with a story problem, and leaving it in exact form is not going to be helpful for us to figure out the number of seconds it takes the paper to reach the ground. So we are going to be writing out some decimals here. So we need to figure out, well, what is negative 21 plus the square root of 537, and then that divided by negative 24, and that gives us approximately negative 0.09. And then if we do that the other way of negative 21 minus 537 divided by negative 24, we get approximately 1.84. Well, we're talking about time here. Does having a negative number make sense for time? No, it doesn't. That's nonsense. So our answer is the second one, and it takes 1.84 seconds. All right, so the last thing we're going to talk about with quadratics is a discriminant. A discriminant is that piece that's underneath the square root sign. And what it does is it allows us to figure out how many answers do we have? 0, 1, or 2, or are they real numbers or imaginary numbers? And this is how it works. If the number that's underneath the square root is a positive number, we're going to have a quadratic function with 2 real solutions. If the number underneath the square root is 0, we're going to have 1 real solution because it's just touching the x-axis. If we have a quadratic function, if we have a discriminant, the number underneath the square root sign is negative, that means we have 2 non-real or imaginary solutions because they don't ever touch the x-axis. So let's take a look at this. We have the equation x squared plus 36 equals 12x. We want to get everything onto one side, so I'm going to subtract the 12x over. And I'm writing it in standard form. Applying my discriminant formula of b squared minus 4ac, I get negative 12 squared minus 4 times 1 times 36. Oops, sorry. I have my keynotes off to the side to make sure I'm going through things right. Well, when I go through and do that, 12 squared is 144. Negative 12 squared is 144. 4 times 1 times 36 is 144 as well. When I subtract those, I get 0. So that means if I were to go through and take this quadratic function and try to solve it, I would get 1 real solution. Meaning I would get 1 real numbered answered solution. And it's only going to cross the x-axis at 1 point. Last one, example 5. Applying our discriminant formula again here, we get 7 squared minus 4 times 1 times 20. When I do this, 7 squared is 49. 4 times 20, I don't know why I'm typing this in, it's 80. Force of habit, I guess. 49 minus 80 is negative 31. Getting a discriminant that's negative means if I were to graph this function, or if I were to try and solve this function and find its zeros, I'm going to end up with it never crossing the real numbered x-axis. It would float above the x-axis. And so what that means for us is our solutions, we have 2 of them, but they are imaginary or complex numbers. So that wraps up the quadratic formula, and this is actually the last lesson in Unit 2A. So make sure that you're working on the 2.6 worksheet. Make sure you communicate with myself or Mr. Brasser if you are struggling or have any questions, and then be on the lookout for a test review guide soon. Thank you so much.